Hi science teachers, welcome to Science Teacher Summer School episode 9. As you can see, the background is different because I'm actually teaching summer school in a different school. I'm Kent Louie, and something you may not know about me is that I joined a meetup group called the Vancouver Tall Persons Club back when I was single and young. I just met the minimum height requirement at the time of 6 feet 2 inches, which would have made me, for the first time in my life, the shortest person in the room. Now, let's get to work. Here's an age-old question. What do we teach? Your initial answer, may be I teach science, or I teach chemistry 11, or whatever your timetable is during the year. Here's a quick shout out to Mark McNeely, retired math teacher, who told me, Kent, we teach kids. Because everything is on the internet these days, it's not so much science content that is the focus of our teaching. The focus is on teaching skills, like processing and analyzing data, communicating conclusions, evaluating bias, and planning and conducting experiments. But science teachers love the content, and I get it. I love the content too. I love balancing chemical equations and writing chemical symbols. I love drawing free body diagrams and stages of mitosis. And I love decoding mysteries of the Doppler effect and redshift. But we are supposed to teach skills in areas of science that can be content heavy too. So, how can skills be taught efficiently in areas of science that are in fact content heavy? We need to consider what content is essential to teach and what we want students to be able to do with that content. For example, we all teach a small unit on lab safety, but how do we teach and assess it to highlight science skills? Typically we talk about lab safety in the class, maybe give a short assignment and then a short quiz where students regurgitate some lab safety facts. However, is that how we really want students to use what they've learned? Simply recalling it and something to check off a list. When I teach lab safety, I take a few minutes to summarize the most important points. Then, I have students do a lab where they brew coffee. It's a simple lab where they use lab equipment to brew coffee, but the point is that they gain some experience conducting a lab safely. And at the end of this lab, I asked them what they felt were the most important safety rules of the day. Finally, when I quizzed them on lab safety, I give them a table full of industry data that shows what injuries are most common in the workplace. And I asked them one question. What do you think is the most important safety rule in the workplace? Analyze the data and formulate an argument using CER. What's important to me is that students practice doing lab safety. And it's also important that they practice science skills, like argumentation and analysis. Now, what I found is that content-heavy areas of science are really good areas at getting students to practice skills, like argumentation, evaluating models, and forming connections between ideas. For example, in another quiz I provide my Science 10s on evolution, I give an illustrated timeline of horse evolution, and I ask one question. Is horse evolution an example of punctuated equilibrium or gradualism? Analyze the timeline and provide an argument using CER. To get started teaching and evaluating science skills through our curricular content, consider the following questions. Number 1, what are the essential pieces of content and skill you want students to know? Number 2, how can I evaluate this effectively and, if possible, creatively? And number 3, how will I know when a student gets it? This last question helps me determine what an A would look like in my class. That's all the time we have for this episode. Please leave your questions, in the comments section below. And join me next time when I'll be sharing how I come up with the 4-point scales on my rubrics. You don't want to miss it. Thanks for watching, and remember to science everywhere, every day.